In this video, we're going to find the limits of functions. For example, number 1, the limit of x squared minus 25 all over x squared plus 2x minus 15 as x approaches to negative 5. In order to find the limits of a function, we need to substitute the value of x to this equation, but we cannot directly substitute it without factoring the terms. So all we need to do is to factor this and this one. Now the factor of x squared minus 25 is x minus 5 and x plus 5. This is a perfect square binomial. If we're going to use the FOIL method, which is by multiplying it, then let's multiply it by the 5 and then this one negative, that is negative 5x, and multiply this one, the outer, negative 25. Cancel this one, and the answer is x squared minus 25. If we're going to factor a term or an equation, we need to have a same answer or value as the example. So it means our factoring is right. After we have factored the numerator, we also need to factor the denominator. And the factors of this denominator is x plus 5 and x minus 3. How do we come up with that? It's like this. X squared plus 2x minus 15. We need to have a two numbers multiplied that will with negative 15. So we have 5 and 3. 5 times 3 is 15, but since this is negative, we need to have a negative sign in one of these. But to know what number should we put the negative, we should see to it that the value, the sign in here is equal when this is being added. So this is 5 and negative. 5 times 3 is negative 15. And 5 plus negative 3 is positive 2. So our factors for this polynomial is right. Now we need to simplify or cancel if there is an equal. So this is cancel. So the answer, the remaining is x minus 5 over x minus 3. We already have a binomial that does not need to be factored anymore. So we can now substitute the value of x with negative 5. Let's come up in here. That is negative 5 minus 5 all over negative 5 minus 3. Negative 5 plus negative 5 is negative 10. And negative 5 plus negative 3 is negative 8. Simplify, so we have cancel the negative sign, that is 5 over 4. So the value of x squared minus 25 over x squared plus 2x minus 15 as x approaches to negative 5 is 5 over 4. That is the answer. Now let's have another example. Okay. What is the limit of 6 plus x squared minus 36 over x as x approaches to 0? In this example, we need to simplify the terms. So 6 plus x squared is equal to 6 plus x times 6 plus x minus 36 all over x. We'll use the FOIL method. 6 times 6 is 36. 6 times x is 6x. X times 6 is 6x. And x times x is x squared. Now copy negative 36 all over x. Combine like terms, we have 36 plus 12x, that is 6x plus 6x plus x squared minus 36 all over x. Cancel, cancel. So the remaining is 12x plus x squared all over x. We can get like terms in here, the x. So x 12 plus x. When we are going to multiply this, then the result is this one. X times 12 is 12x. X times x is x squared all over x. We are doing this to cancel the remaining variable. So the remaining is 12 plus x. We can now substitute the value of x to this. So 12 plus 0 is 12. Now this is the answer. Now what if we're going to find the limits of a functions with radical sign? To get rid of the radical, we need to multiply it by its conjugate. When we say conjugate, we are multiplying the same variables, the same value, but using its opposite sign. When this is negative, we're going to put or use a positive sign, its opposite sign. And we're going to put it in the numerator and denominator. It's like adding a 2 over 3 times 1 over 1. When we are going to multiply this to this, the value does not change. So if we're going to multiply it to this, it's like 1 over 1. So the value of this does not change. But if we're going to use this, we can cancel the radical sign. So how does it work? When we are going to multiply the radical and radical, it will now be cancelled. So the answer is x, that is cancelled, cancel. Negative times positive is negative. 2 times 2 is 4. And then copy the remaining, that is multiplication sign. So we need to copy that multiply it by x negative 4, and then we're going to cancel same terms. So the remaining is 1 over the square root of x plus 2. We can now substitute the value of x with 4. So 1 over 4 square root of x plus 2. That is 1. The value of x is 4. That is square root of 4 plus 2. That is 1. The square root of 4 is 2. It's 2 times 2. That is the square root. So the square root of 4 is 2 plus 2. So the answer is 1/4. Now let's have another example. You can pause the video in order for you to try our example. Now what is the limit of x all over 3 minus square root of x plus 9 as x approaches to 0? In this kind of example, we're still going to use or get the conjugate of this radical. So that is x all over 3 minus square root of x plus 9 times 3. We're going to eliminate the radical. The radical is in the denominator. So we're going to use 3. Then the opposite sign is positive. Square root of x plus 9 all over 3 plus square root of x plus 9. Then let's multiply it. It's x times 3 plus the square root of x plus 9 all over 3 times 3 is 9. Negative times positive is negative. X plus 9 plus times x plus 9 cancel. So that will be x plus 9. We have to put the parenthesis since we have a negative sign in here in order for us to distribute it later. Now, let's copy x 3 plus square root of x plus 9 all over 9 minus. Let's distribute the negative sign. Negative x and negative 9. We can cancel this. Negative 9 and positive 9. So the remaining is x 3 plus square root of x plus 9 all over negative x. We have same value, so we can cancel that. And the answer is 3 plus x plus 9 all over 1. Don't forget the 1 since it has a negative sign. Then we can now substitute the value of x. That is negative 3 plus square root of 0 plus 9 all over 1. That is negative 3 plus square root of 9 all over 1. That is negative 3 plus what is the square root of 9? That is 3 all over 1. And so the answer is negative 6 all over 1 or negative 6. Some teachers would basically want this answer because we need to simplify it. So the answer is negative 6.